SOTA. I'm a master degree student in data science department, and today I'm going to talk about a review paper on vulnerability of the state-of-the-art face recognition model to template inversion attack. So what is facial recognition system? It is a technology that identifies or verifies a person by analyzing and comparing facial feature from a video on images. It is mostly used in biometric recognition system and used for entertainment and social media, as you have used it in your mobile device or laptop, where you use it to authentication to unlock your device. It works by scanning a face and separate that face from a background, and then using a deep learning model, it then extract the feature from the face and generate a unique numerical value, which is called embedding, and store it in a database. And when you rescan your face again, it then will extract a new feature from that face and then compare with the stored embedding in the database. If the similarity is close enough or the same, you will be able to unlock that device. So in this paper, the template inversion attack is just a process of reverse engineering using that embedding to reconstruct the original image or a new image that's close to the original image and break into the facial recognition system. The process of template inversion consists of two processes, which is convolution process and deconvolution process. The convolution process is just a process to extract the feature from an image. It is mostly used in facial recognition. And the deconvolution process is the opposite of the convolution process. In the attempt to do template inversion attack, there are two scenarios that based on the available information about the facial recognition model. One is the white box scenario, and the second is the black box. The white box scenario provide all of the information about the model that is available to the attacker, from the parameter of the facial recognition model to the training dataset that used to train the facial recognition model, while the black box scenario provide no information about anything to the attacker, which means the attacker has to guess about everything to try to attack the facial recognition model. In one of the related work, the template inversion attack used a FaceNet model mapping, which provide an example face and then two embeddings, and then using that embedding to generate a new face followed by that example. As we can see, the output might be close or might not be close depending on the embedding, which is not a good result. So in this paper, the author proposed a new framework to evaluate the vulnerability of the facial recognition system to the template inversion attack. The author provided with the threat model, the face reconstruction network, and the evaluation of the vulnerability using mostly done by comparing the cosine similarity of the reconstructed image. So the threat that was introduced have four main strategies. First is the goal to impersonate the attacked person in the target facial recognition system. The second is the knowledge, which the attacker is assumed to have the stored face template in the database and is given a white box scenario. But the attacker is also assumed not to have information about the target, which like the race, the gender, the height, anything. And then also the decision-making threshold is not provided. Third is the capability where the attacker can directly inject the reconstructed face into the target system bypassing the sensor, mostly the camera. And the fourth is the strategy where the attacker used the reconstructed face from the target template and then use it to query it into the target facial recognition system. Or the attacker can do a presentation attack to unlock the system. So in the neural network, for the face reconstruction, the author first generating a training dataset that use an augmentation training dataset. The reason for using an augmentation for the dataset is because the augmentation will allow the dataset to be robust and perform well under the template inversion attack. This will be shown later in the experiment. But the augmentation consists of adding noise to the dataset, applying color PCA, applying brightness, contrast, and applying Gaussian blur to the reconstructed images. These will help the images to focus solely on the template, on the embedding. And the augmentation of the dataset is then trained with multi-term loss, which is the mean absolute error, dissimilarity, structural index matrix, perceptual loss, and ID loss, which the combination of cosine similarity and the L1 norm, which is the most important in this multi-term loss function. So in this paper, the neural network structure was introduced, which is DSCasConv. It's an enhanced deconvolution using cascade convolution with skip connection. In each DSCasConv, it's applied multiple cascade convolution to the deconvolution output, which means we have an image or an input applied through a deconvolutional layer, and that output will then go through multiple convolutional layer while forcing the convolutional layer to learn the previous learning residual or an error, and then at the end it will learn a skip connection of the previous deconvolutional layer so that it can improve the deconvolutional output. So in the proposed neural network, the template will have to go through 6 DSCasConv block, which are shown in the picture below, and each block will consist of 1 deconvolution and 3 convolution operation, and contain 5, 12, 256, 128, 64, 32, 16 filter respectively. And also the deconvolution operation will use a 4x4 kernel, and the convolution will use a 3x3 kernel. At the end of each operation, a batch norm and rectifier linear unit will apply, and at the end of the output of the last DSCasConv, the output will have to go through 4 parallel convolution layers, which have the different size kernel of 1, 3, 5, and 7. And then after output of those convolution layer, it will have to go through a sigmoid function to generate a reconstructed face image. So in the experiment, the model that has been chosen as a primary model is the ArcFace, IResNet 100 ArcFace. It is trained on FAQ dataset, which consists of 70,000 clear images, and it tests on Mobio, label face in the wild, and HDB datasets. The author employed the Adam optimizer, which is set the learning rate to 10 to the minus of 3 and decreased by half every 10 epoch. And the training of the reconstructed network using FAQ was trained with 90 epoch, and with the trained test split by 90% to 10% respectively. The training was done by leveraging the multi-term loss, which is the mean absolute error, dissimilarity of index matrix, perceptual loss, and ID loss. So we can see that using Mobio, label face in the wild, and HDB, the template inversion compared to the genuine images is closely or are comparable to the genuine images that has been used. So the experiment has been done another way using Mobio, the same dataset such as Mobio, label face in the wild, and HDB. It was done to see the effectiveness of the losses. There have been divided into 6 losses, which have been shown to L1, L2, L3, L4, L5, and L6. The L6, which is the combination of the whole multi-term loss, has been shown on the graph on the right, has the most well performance out of all of the losses, even though L1, L2, L3 is supposed to be the best, but applying with L6 with the combination of ID loss of L1 and cosine similarity, it's shown to be the best, even though the dataset is still the worst. And then to investigate if any weight is affect the performance of the template inversion, the author also tests by doing a weight tuning on each of the weight of the dissimilarity index matrix, perceptual loss, and ID loss. And the last weight of the ID loss have the most effective on the performance. So that means the ID loss consists of cosine similarity and L1 norm has to be combined to have the most impact on the performance. And for the experiment, the author used another network to reconstruct the face image, which used deconvolution, NBNet A and NBNet B. The comparison was done by generating images, as we can see on the left. The images that has been generated is good, but still have a lot of artifact compared to the proposed methods. And the loss that has been given to all of the model, we can say using the loss function that has been given, achieve the best result in any situation. And another experiment was done by using data augmentation and data without augmentation. And the data augmentation provide with the best result, best quality, and the number of cosine similarity is higher than data without augmentation. And another experiment was done by using other facial recognition model, which is also done by using elastic face, ADA face, edge face, and pocket net, which are high performance facial recognition model. So in conclusion, the higher the recognition performance, the higher the vulnerability of that to the template inversion attack, and it is a threat to the privacy of the user, which shown the race, gender, and age, etc. Thank you.